All right, so we learned about getting and posting. Let's talk about REST. Right. So REST is a set of conventions that we have identified as being good practice to follow when we are building these URLs. Notice that when I was building my URL, I just say, let's call it new course, right? Or get me all my courses. So those URLs, you can put whatever you want, as long as they're unique, obviously, within your context. Yes? All right? But there's actually a good practice on how you should name those URLs. And not just the name. Those URLs can have a format. They can have a syntax. They can have meaning. So REST, or representational state transfer, right, is a set of conventions that drive how we should create those URLs. Right? Those URLs are actually very important. Presumably, they will uniquely identify resources in the entire world. Right? In a global network, you could uniquely identify any resource. You're just like a phone number uniquely identifies you in this planet. Right? When Elon Musk gets us to Mars, we'll have to think of a planetary area code or something that uniquely identifies us in the solar system. But URLs right now identifies us uniquely in this planet. Right? And so we would like to be able to uniquely identify data, or any resource in general. Okay? So we have to think about what names do we want to use. We know the domain name is going to be unique. Right? We're going to own that. Nobody else can have that domain. So that makes us already unique in a particular context. Right? But after the domain, we can choose any URL under that. Yes? Well, even there we shouldn't be frugal or be whatever. Well, you can name it whatever you want. No, we should follow certain conventions. And that convention is driven by the data structure by the schema that you want to map in a relational database or in a class diagram or whatever, object-oriented data model. So you already have a data model in mind. Presumably you have courses and sections and enrollments and whatnot, yes? Right? So, and you have a structure. You have inheritance and you have one-to-manys and many-to-manys. So that structure should drive the structure of that path, of that URL. Make sense? All right, so let's talk about that. Okay. And also so that's one idea. That's one concept. The other concept is that URL should uniquely identify a particular state that your application is in. Right? As your application interacts with users, as data is coming in and data is coming out, and you're retrieving data and putting data and modifying data, right? Your application transfers from one state to another state, right? And ideally, those URLs would uniquely identify where is your application currently. What's the current state of your application? You can ask the application, what is your current state? Or it would allow you to change that state, from one state to another state. So these URLs are fairly important. Right? Not only do they map to some data structure, it also allows you to presumably have your state transition between multiple valid states. Make sense? All right. So based on that, let's take a look at this. So first of all, we need to be able to do the common 4 operations, on our data. That's what we want to interact with. Data, yes? And data, there are 4 basic operations. We need to be able to create new data, retrieve existing data, modify existing data, or remove existing data. Right? So those are the 4 basic operations. Right? If we're using HTTP, because we could be using many other encoding and other infrastructure, but since HTTP is the most common, we're going to use as a convention these 4 methods or verbs: post to create, get to retrieve, put to update, and delete to remove. Make sense? That's one of the conventions. Right. So whatever URL you're passing, the action post, put, delete, and get, right, should be used with this meaning. If you're creating new data, you are using a post. So that's one of the conventions. The other convention is based on the data structure. How is your data represented? How is it organized? Right? So for instance, let's look at this very generic data structure. Right? You have A having one-to-many with B, B one-to-many with C, C having one-to-many with D. Yes? So it has a structure. Right? So this is a very, very simple structure. It just has an ID. That's all it is. Right? So the syntax, yes?
Is there any difference between HTTP operation and state, not the state transition, just the state?
Well, other than HTTP being stateless, right? HTTP does not maintain any state, right? The state would uniquely be identified by your application state. So we're not talking about HTTP state. We're talking about application state, right? And so that URL presumably maps to a particular state of your application, or forces it to transition from one state to another state. You know, more courses, less courses. I change the course. If, for instance, if the state hasn't changed and I ask for the list of courses, and I always ask for the same list of courses, I will always get the same list of courses. So my state hasn't changed. So that URL should always map to the same state. So these are the list of courses. If there's another URL that comes in that adds a new course, so that transitions my application from having 3 courses to 4 courses. When I then ask for a list of courses, I will always get now 4 courses instead of 3 before, right? But it's stateless in that it's functional in that if I ask the same question, I always get the same answer, right? So in that sense, the application is maintaining that state, whether it's presumably it would be saved or persisted to some database, right?
Because it seems that the word state is derived from DFAs, where we are moving from one state to another in an automaton.
Yeah, we mean that way, right? It would be some presumably when you're doing architecting your application. Presumably, you have come up with some finite state machine representation of the valid states that your application can be in. Yes, certainly. And presumably, you've
States with respect to HTTP because again it's stateless.
exactly. So it would be supported by a state based on a database. The database would be maintaining the state. Yeah. There's an additional state application state as in HTTP sessions, right? Maintaining cookies and whatnot. That's another type state, and we'll talk about that a little later. But yes, that would also that's only for a convenience of being able to remember things between requests, which is not the same thing, right? Where was I? Right. So they're presumably. Let's look at right. So one of the conventions is that we're going to use those 4 actions, right? That's a convention, right? This is not how do you say it? It's not an infrastructure. There's no validation here, right? It's an architectural set of conventions, right? REST. And most APIs today, when you interact, are RESTful, right? Or they'll say they're RESTful, but they don't follow the conventions that would make it truly RESTful. All right, so let's take a look at this structure. This is a very simple structure for data. So based on this very simple structure, the URLs that you would use would be as follows. Right? So presumably A represents all the set of records that are of type A. Yes? And B presumably represents all the data points, the data set that are of type B. Right? So presumably you have the table that you have stored all the records for A, table B, table C, and table D. But not all records in B are related to a particular record in A. Yes? We know that there's only a subset of records in B that are related to a particular record in A. Yes? That's a point of having a one-to-many relationship. Right? There's only a subset of B's that are related to A. And same thing, there's only a subset of C's that are related to a particular record in B. Make sense? So presumably, this A to B to C to D defines a hierarchical structure where presumably you can start at any point in A, and you should be able to navigate down to all the B's that are for that A. And then if you choose a particular B, you should be able to navigate to all the C's for that particular B. Yes? And then if you go down to D's and whatnot. Correctly? So presumably what we'd like to be able to do is to provide a mechanism that would allow us to navigate this hierarchy, right, that has A as the root and then branching up to B's and the C's and the D's. Okay? Well, we know of a mechanism that allows us to do something like that. For instance, the path, using a path to navigate a directory structure is very similar. The directory is also very hierarchical, starts at the root, and then following a path, it allows you to navigate up and down all these branches and all these leaves, and to list or navigate through to any file or any directory. Make sense? So the path, right, is a very useful mechanism that would allow it to navigate this hierarchical data structure. So if you say /A, right, the interpretation or the meaning would be that you are referring to all instances of A, right, or all records of A. All right? If you say /A / followed by a particular unique identifier, or so some primary key, then the meaning of that would be that you're referring to a particular record that has that particular primary key or a unique identifier. Make sense? All right? Combine that with the verbs or the actions. Now we have a full set of vocabulary to be able to transfer the application from any state to another state, or ask the application of any state, at least for the set of A's. So post /A would be interpreted as I want to create. That's what post says. /A is the set of A, so I want to create a new instance, a new record. Right? I want to add a new element or record into the set of A's. So that would be the interpretation. Right? If instead I say get /A, so the same URL but a different method, the interpretation is that I want all instances of A. So retrieve from me all the records for A. Right? Or if I want a particular record, I could perhaps add a primary key next to it. So it would be /A / and then the ID, the unique identifier. You know, I want that particular record. Okay? A put means that you want to modify something. Right? So presumably you're modifying something that already exists. So perhaps it might make no sense to do a put /A, right? Since you can't modify the entire set, or maybe might have some meaning in your very unique application. But typically it would be put /A / and some unique identifier, because you're modifying a particular instance. Or delete /A / and then the unique identifier, you're removing that particular record. Make sense? Right? So with those 4 or 5 operations, you pretty much can do everything you want with all the records in the set A. Everybody okay? Make sense? All right. All right, excellent. So we've only considered the set of all A's. Let's go a little further and let's go down to the B's. Right. So the B's, we're considering B. Well, presumably there's a relationship between a record in A and a record in B. Right? That's what the diagram says, right? That there are some records in B that are associated to a particular record in A. Which record in A? Well, presumably that would be part of the URL. The URL would specify, you know, A, in the set of A, there's a particular record, 1, 2, 3, that has several B's that are associated to this one record. That's the one-to-many. Right? So /A, 1, 2, 3, /B means all the records in A, in B that are associated to A, to that particular record in A. Make sense? Right? And if you post to that set, that means that you're creating a new B that is also associated to that record A. Right? Or if you're saying a get, that means retrieve from me all the B's for that particular record of A. Right? So /A / 1, 2, 3 /B. That make sense? Pretty good? And if you do a get, right, you could specify, I don't want all the B's, I want a particular B, because I know their primary key but it's a particular B that I know is related to A, right? But notice here that there's a little redundancy. Now, if I can guarantee that these IDs for B are unique, notice that /A123, right? It's kind of redundant, or it's unnecessary to have that context, right? It's unnecessary to have the context because I already know the primary key of B. Okay. Now this is true if you're using, for instance, relational databases, right? Because each record in B is guaranteed to have a unique identifier, right? So there's no need for the context of A. I don't need the foreign key A. Yes. But if you're using instead other forms of storage, such as XML, or you're storing it as a JSON JSON object, right? Then typically it will not be stored in separate tables or separate collections. It'll instead be stored as a nested object inside of a parent object. So in that case, the unique identifier of B is not enough, right? Because I have all the A's, I don't know which A to look at to find my little B, right? So I do need the context so I can navigate from a particular A down to a particular B. But in a relational database, you don't need that, right? Because in a relational database, these records would be stored in separate tables, right? And they are guaranteed to be unique. So it depends. If you're using XML or JSON, or depending how you structure in your data, then you need the entire context, /A, 123, /B, 234, right? But in a relational database, it's kind of unnecessary, and you can do the shortcut of just using /B, /234. Make sense? Right? Again, use one or the other depending on your particular implementation. Okay? All right, let's keep going. All right, so we were using a course. Courses, modules, and sections. All right. So for instance, here we have post course. Presumably we're creating a brand new course. Get course, retrieving all the courses. Get course 1, 2, 3. Put course 2, 3, 4. Delete course 3, 4, 5, and whatnot. Yes? So we would do something similar. We could do something similar like that. If we have here, where is it? Course service. Let's see. We can, for instance, we would have, according to the RESTful conventions, we would have something like this. At post mapping would be /course. That would be preferable, right? Course. So actually, let me do that. All right, so you would have a mapping to the entity object or the record or the table that you're interacting with. So it's course, and you would be adding things. The other one would be if you're retrieving all the records, then you would be doing a get. You would be doing get mapping and /course, and here you would be just retrieving public. Just copy this. We'll be doing something like find all courses. Would have nothing in the body. There's nothing in the body because it's a get, and we would be just returning just a list of courses. That's it. Yes? All right. If we're retrieving a particular course, it will look something like this: /course /course ID, and this would be maybe find course by ID, and would retrieve just one course. And presumably we would pass the course ID as part of the path. So it would be something like a path variable called course ID, which we're going to parse it as an integer and map it to this local variable ID. And so presumably we're going to iterate over all the courses in my courses. And if that course ID is equal to the ID that we want, then we're just going to return that course. and be done. If I can't find it, I'll just return null. Make sense? Right? Plus all the puts and all the deletes will be there as well. Right? So if we restart here, we can do here a new query. We're going to get this, the same. The same would be this course. It's a get. We're going to do a get. Let's see. It comes back with an empty array because the server restarted. I lost all the courses I created earlier. We can create them again. Let's see. And we renamed it to course following the naming convention. Let's save that. Let's post it. There it is. There's my course. Let's create another one. Let's create yet another one. There we go. We have 3. Here we have a find all. Let's save this as find all. Save that. Let's run it. Notice that it returns all of them, obviously. Yes. Returns all of them. Or let's clone this. I will call this find course by ID. So this will be course, and what do we have there? We have 456, 345. So let's return this 345. And let's retrieve that. There it is. It retrieved only that object. We have another one. Let's retrieve this 123. 123. It retrieves 123. Make sense? All right. This is just using the object in memory. Obviously, what we want to do is map this to a database instead, right? So let's talk about that next. All right, excellent.